Hi guys, let's look at the next question. The next question that we do is question number 8. A body of volume 100 cubic centimeter weighs 1 kilogram force in air. Find its weight in water and its relative density. Now we'll solve this question using two methods. The method one I'll use will be the method that we've already learned in exercise A, which involves upthrust. And method two would involve the new formula that we've done in this exercise. So let's first calculate the upthrust method. So the volume is given equal to 100 centimeter cube. Weight in air is given equal to 1 kgf, which we can take as 1000 gram force, which means mass will be equal to 1000 gram. Now, if I calculate the upthrust on this, upthrust would be equal to volume of solid, in this case 100, multiplied with density of liquid, in this case 1, multiplied with G, which means this would be equal to 100 gram force. Therefore, weight in water, which is basically the apparent weight, would be equal to 1000 gram force minus 100 gram force, which would be equal to 900 gram force. If you want to give the answer in the form of a kilogram force, then this will be 0.9 kgf. That's one way of solving this question, exactly the way we'd done it last time or in the previous exercise. Now let's use the new formula that we've learned in this exercise, which uses Archimedes principle, which says a relative density of a solid is equal to, this is of the solid, is equal to weight in air upon weight in air minus weight in liquid multiplied with RD of liquid. Perfect. So this is something that we already know. Let's see if we can calculate the density of the liquid. So density is equal to mass upon volume. Both the mass and the volume are given. If I take the mass as 1000 gram, this is what is there from point 3 upon volume is 100 centimeter cube. Therefore, density of the body becomes 1000 upon 100, that's 10 gram per centimeter cube, which means a relative density of body is 10. So that answers the first part of the question. Rather, the second part of the question, this is the same method that we'll use here as well, but so that's the relative density. Now let's apply it in this formula. So I have 10 is equal to weight in air. The weight in air is 1000 upon weight in air, which is again 1000, minus weight in liquid, let's say X, multiplied with relative density of liquid. This is water, which means the relative density is 1. Let's cross multiply. So 10 into 1000, that's 10,000, minus 10x is equal to 1000, which means 10,000 minus 1000 is equal to 10x, which means 9,000 is equal to 10x. Therefore, x is equal to 900, and this is weight, so gram force. Therefore, weight in water is equal to 900 gram force, or 0.9 kilogram force. So whichever method you want to use, you can use that method. I have shown you both the methods for this question. From the next question, I'll be using only the new method, which is involving the formula. Let's go ahead and look at the next question. The next question that we have is question number 9. It says a body of mass 70 kilogram. So mass is given equal to 70 kilogram. When completely immersed in water, displaces 20,000 cubic centimeter of water, which means volume of body is equal to 20,000 centimeter cube, because a body will displace water which is equal to its uh, own volume. Since this is given in kilogram, let me convert this into meter cube. So this would be divided by 6, 10 to the power 6, which would mean this would become 0.02 1, 2, 3, 4, 5, 6. Yes, 0.02 meter cube. Next, we need to find the weight of the body in water and we need to find the relative density. So let's first find the density. Density is equal to mass upon volume. Mass is given as 70 and this is 0.02 and the unit would be kilogram per meter cube. Let me remove the decimal. So this would be 70 multiplied with 100 and the denominator becomes 2. So this is 2 into 1 and this is 2 into 35. So this is 3500 kilogram per meter cube. So we've calculated the density. Now let's calculate the relative density. The relative density would be equal to 3500 upon the density of water in kilogram per meter cube. So that's 1000. Therefore, RD would be equal to 3.5. So one part of the question, which is RD of the body, done. Let's try and solve the second part. It says the weight of the body in water. So using the formula, we know relative density is of solid would be equal to weight in air divided by weight in air minus weight in water multiplied with relative density of water. In this case, the fluid is water. So relative density of the solid is 3.5 is equal to weight in air, which is 70, which means I will write the weight is equal to 70 kgf. So this is 70 kgf upon weight in air, that's 70 kgf minus weight in water, let's be x, multiplied with relative density of water, that's 1. Let's cross multiply. So that's 70 into 3.5. That's 210, 35. That's 245. So this is 245 minus 3.5x is equal to 70. That 3.5x is equal to 245 minus 70. X would be equal to 245 minus 70. That's 175 upon 3.5. Yes, this is fine. So that'll be 7 into 0.5 and that's 7 into 2, 14, 35. So that's 7 into 5. This is 0.1 and this is 50. Therefore, weight in water is equal to 50. What units were we working with? Kilogram. So this is 50 kilogram force. That's the weight in water. Done. Let's look at the next question. If you have any doubts or queries, you're welcome to ask me on the channel that I have here. Let's look at the next question. The next question is question number 10. It says a solid weighs 120 gram force in air and 105 gram force when completely immersed in water. So point number 1, weight in air is equal to 120 gram force. Let's call it W1. Number 2, weight in water is equal to 105 gram force is equal to W2. We need to calculate the relative density. We know relative density of solid would be equal to W1, which is weight in air, upon W1 minus W2, which means weight in air minus weight in fluid, multiplied with relative density of fluid. In this case, let's apply the units or substitute values. This is 120. This is 120 minus 105 multiplied with 1. This is equal to 120 upon, that's 15. Therefore, relative density of solid is equal to 8. 120 divided by 15, that's 8. Simple question. If you refer to your book, they have given you two formula. Formula 1 is when it is immersed in water. In that case, they are calling the density or the relative density as weight in air upon weight in air minus weight in water. That's formula 1 given in your textbook, or rather the Selina book that you have. Another formula given is relative density of the solid is equal to weight in air upon loss of weight, which is let's call it, instead of loss of weight, let's write it in the form of formula, weight in air minus weight in fluid multiplied with RD of fluid. So I use only the second formula because even if this is water, then instead of fluid, I'll write weight in water and relative density of water, which is 1. So I remember this specific formula. I work on all questions using this formula. Right, let's look at the next question. The next question that we have is question number 11. It says a solid weighs 32 gram force in air and 28.8 gram force in water. So let's write the information. Weight in air is equal to W1 is equal to 32 gram force. Point number 2, weight in water is equal to 28.8 gram force. Let's call it W2. We need to find the volume and we need to find the relative density of the solid. So we know relative density would be equal to W1 upon W1 minus W2 multiplied with density of water, which is 1. Or rather, not density, relative density of water. So W1 is 32 upon 32 minus 28.8. This is equal to 32 upon, that's 3.2. Therefore, RD is equal to 10. So the first part of the question, which is find the RD of the solid, done. RD of the solid is 10. Next part of the question, find the volume of the solid. So this was part 1. Let's look at part 2. So volume of the solid would also be equal to 3.2 centimeter cube. Why is that? Let's calculate the upthrust first. So, or rather, let's calculate the density. So density would be mass upon volume. Density we've just calculated as 10. So that will be 10. Mass is 32 upon volume, which means volume is equal to 32 upon 10, which is 3.2 centimeter cube. Right, let's look at this formula again. Density is equal to mass upon volume. Density we just calculated as 10. This is relative density, which if you convert it into the CGS unit becomes 10 gram per centimeter cube. Mass is 32. Mass is equal to 32 gram. Volume we need to calculate. So the volume is 3.2 centimeter cube. Next, weight of solid in a liquid of density 0.9. So for part 3, we will use that formula again. Weight in liquid, let it be X gram force. So the formula is relative density of solid is equal to W is equal to this, which will be W1 upon W1 minus X multiplied with the relative density of liquid. The same formula that we've been using. Let's substitute values and see what we get. The relative density we already know is 10 is equal to W1, which is 32 upon 32 minus X multiplied with 0.9. Correct? That's correct. 32 upon 32 minus X is 0.9. Let's cross multiply. 320 minus 10X is equal to 32 into 9. That's 270 and 18. That's 288, which means with a decimal, which means 10x is equal to 320 minus 28.8. Let's subtract 320, 28.8. That's 10 minus 8, 2, 9 minus 8, 1, 11 minus 2, 9. That's 291.2. Therefore, 10x is equal to 291.2. Therefore, x is equal to 29.12 gram force. Therefore, weight in liquid is 29.12 gram force. Done. That finishes this video for me. I'll see you with the next video. Meanwhile, take care and be safe. Bye bye.